faster than the fabric of spacetime can keep up with it, and it'll just rip. And I'm terrified by this. A cosmic spectacle is unfolding as we speak, captivating astronomers worldwide. Betelgeuse, that mesmerizing red supergiant adorning Orion's shoulder, is undergoing a remarkable metamorphosis. Its luminosity, the radiant glow that defines its celestial presence, has undergone an extraordinary surge, surpassing its customary brilliance by an astounding 50%. At the dawn of this year, Betelgeuse proudly held the illustrious title of the 10th brightest star gracing our nocturnal canvas. However, this unexpected celestial glow-up has propelled it to a prestigious new position, now shining brightly as the 7th star in our inspiring night sky. Betelgeuse, a massive star in its late stages of life, is of immense size. Its dimensions are so vast that if it were positioned at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse resulting in a powerful supernova explosion, which may lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova stems from the fact that it will be an extraordinary event. Positioned roughly 650 light-years away, humanity finds itself in an optimal location to witness this cosmic spectacle firsthand. When the stellar explosion occurs, it will produce a breathtaking display of light. Initially, there will be an abrupt influx of neutrinos that will sweep across the Earth, detectable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly intensify in brightness over the course of a week, reaching up to 100,000 times its usual luminosity. Depending on the explosion's power, this celestial beacon could rival the brilliance of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This magnificent event will persist for an extended period, offering an unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse may trigger speculation and apprehension due to historical associations of such events with ill omens, we can take solace in the fact that we are safely situated at a considerable distance, shielded from any detrimental effects. To fully comprehend the enigma surrounding Betelgeuse, it is crucial to revisit the end of 2019. During this period, the red supergiant star started experiencing significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope in the optical spectrum revealed that Betelgeuse appeared roughly symmetrical, but its photospheric layers exhibited signs of substantial disturbance. Within our line of sight, the photosphere represents the outer layer of the star where light is emitted. Researchers also detected an expansion of the photosphere, giving the impression that the star was swelling when viewed from Earth. This expansion continued at a constant rate of approximately 8 kilometers per second for most of the year until mid-November 2019, at which point the outward velocity began to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. These revealed two surprising irregularities. Firstly, a darkened region appeared in the star's southern hemisphere, creating a striking contrast with the previous image taken at the beginning of the year. Secondly, the surface temperature of the star experienced a dip, dropping by approximately 80 Kelvin between January 27th and February 13th, 2020. The brightness of Betelgeuse reached an unprecedented low approximately a year after the cessation of the outflow. However, the star gradually regained its brightness over the following months, eventually returning to its normal magnitude. This led to the question, what had truly happened with Betelgeuse? All the available evidence strongly suggested that Betelgeuse had undergone an immense and unprecedented event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better comprehend SME, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges upwards and outwards, causing shock waves within its atmosphere. Over time, this material forms molecules and dust, partially obstructing our view of the star and causing it to appear dimmer. In the case of Betelgeuse, the SME resulted in the ejection of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This amounted to multiple times the mass of the Moon, propelled at astonishing speeds. Researchers noted that such an enormous mass ejection from a star's surface had never been witnessed before. The event allowed for the direct observation and examination of surface details using the Hubble telescope, offering a real-time glimpse into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This occurrence demonstrated that a dying star can experience substantial mass loss beyond its regular annual decrease due to stellar wind. In a way, it was as if Betelgeuse had forcefully expelled its upper layers and was presently in the process of slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior has undergone a change. Previously, it would pulsate or alter its brightness every 400 days, but now it is pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to variations in its size and temperature. This red supergiant is known to exhibit two main periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulsations in the fundamental mode. The second period is a longer cycle of approximately 5.6 years, and its origin remains unknown. In their research paper, scientists utilized computer simulations to gain a deeper understanding of the events that transpired. They proposed that an unusually hot gas current, resembling a large and intense bubble, emerged from within the star. These occurrences of hot gas bubbles occasionally arise due to the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is constantly in motion and mixing. As this hot bubble ascended and broke through the star's surface, it triggered the ejection of stellar material. Interestingly, it also disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to transition from its customary 400-day pulsation to a new 200-day pulsation. Astronomers anticipate that the star's regular motions will gradually stabilize the unusual pulsation over the next 5 to 10 years, ultimately restoring Betelgeuse to its normal 400-day pulsation. Regarding the possibility of a Betelgeuse supernova, astronomers speculate that it could occur at any time within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a cataclysmic explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening at present would only become visible to us after 650 years due to the limitations imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's traumatic demise during our lifetime. The unique thing about Betelgeuse is that we can actually see its surface, which isn't the case for most other stars. This gives us an incredible opportunity to learn about how big stars like Betelgeuse behave as they get older, including these kinds of surprising mass ejection events. Recently, astronomers made a bone-chilling discovery. For the first time ever, they observed a star eat its own planet 12,000 light-years away in the constellation Aquila. Betelgeuse, with its intriguing name and prominent position in the night sky, has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has left its mark on pop culture and mythology around the world. Betelgeuse has a rich and diverse origin rooted in the Arabic language. Initially interpreted as the armpit of the giant, some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often linked to anthropomorphic or animal figures across different cultures and mythologies. Betelgeuse carries multifaceted meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the moist one, tied to Hindu astrology's Ardra lunar house and associated with the tempestuous storm god Rudra. Throughout history, Betelgeuse played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals and agricultural life in villages. In other regions, such as North Baffin Island and the Melville Peninsula, its rising marked the onset of spring and longer days. Betelgeuse's cultural prominence stems from its affiliation with the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, it captivates and inspires artists, writers, and filmmakers. There's just so much more to talk about on this topic. What are your thoughts on the recent metamorphosis of Betelgeuse and its potential for a future supernova? Betelgeuse, also known by its scientific designation Betelgeuse, continues to intrigue astronomers and enthusiasts alike with its dynamic behavior and potential for a spectacular supernova event. Situated in the constellation Orion, this red supergiant star has long been a subject of fascination due to its size, luminosity, and evolutionary stage. One of the most captivating aspects of Betelgeuse is its sheer size. As a red supergiant, it has expanded to immense proportions compared to our Sun. Estimates place its diameter at approximately 1,000 times larger than the Sun, making it one of the largest known stars in our galaxy. This immense size is a result of the star's advanced evolutionary stage, where it has exhausted much of its nuclear fuel and begun to swell. The luminosity of Betelgeuse is another striking feature. Despite its vast distance of around 650 light-years from Earth, it remains one of the brightest stars in the night sky. Its luminosity, or intrinsic brightness, varies due to its pulsations and occasional eruptions like the surface mass ejection observed recently. These variations allow astronomers to study its physical properties in detail, providing insights into the late stages of stellar evolution. In addition to its scientific importance, Betelgeuse holds a prominent place in cultural history. Across various civilizations and mythologies, the star has been interpreted and celebrated in diverse ways. In Arabic astronomy, it was traditionally known as Ibt al-Jawza, meaning the armpit of the central figure in the constellation Orion. This name later evolved into Betelgeuse in European languages. The symbolism and cultural significance of Betelgeuse extend beyond its astronomical characteristics. In ancient cultures such as Egypt and Mesopotamia, stars like Betelgeuse were associated with deities and myths. They were often seen as celestial beings or manifestations of powerful forces in the universe. Betelgeuse's position in the constellation Orion, a prominent figure in Greek mythology, further adds to its cultural allure. From a scientific perspective, Betelgeuse offers a unique opportunity to study the final stages of massive star evolution. As it nears the end of its life, the star undergoes complex processes such as fusion of heavier elements in its core. This fusion process releases enormous amounts of energy, which eventually leads to the star's demise in a cataclysmic supernova explosion. The potential for Betelgeuse to undergo a supernova event has been a topic of intense speculation and research. While astronomers cannot predict the exact timing of such an event, they continue to monitor the star closely for any signs of impending collapse. A supernova from Betelgeuse would not only be a spectacular cosmic event visible across vast distances, but also a critical opportunity for scientific investigation into stellar evolution and the formation of exotic objects like neutron stars and black holes. Recent observations and studies have provided new insights into Betelgeuse's behavior and variability. For instance, the star's recent dimming and subsequent recovery raised questions about its internal processes and stability. The surface mass ejection observed in 2019 to 2020 was a significant event that shed light on the star's dynamic nature and its impact on surrounding interstellar environments. Technological advancements in observational astronomy have played a crucial role in our understanding of Betelgeuse and other celestial phenomena. Telescopes such as the Hubble Space Telescope and ground-based observatories, equipped with advanced spectroscopic instruments, have enabled astronomers to analyze the star's light spectrum in detail. These observations reveal information about Betelgeuse's chemical composition, temperature variations, and atmospheric dynamics. Beyond its scientific and cultural significance, Betelgeuse serves as a reminder of the vastness and complexity of the universe. Studying stars like Betelgeuse helps us unravel the mysteries of stellar evolution, from birth to death. It provides valuable data for theoretical models and simulations, refining our understanding of astrophysical processes under extreme conditions. In addition to its astronomical importance, Betelgeuse's visibility in the night sky has made it a favorite target for amateur astronomers and stargazers. Its distinctive reddish hue and prominent location in the constellation Orion make it easily recognizable even without telescopic aid. Observing Betelgeuse over time allows enthusiasts to appreciate its variability and dynamic nature firsthand. The study of Betelgeuse is not limited to visible light observations alone. Astronomers also utilize other wavelengths of light, such as infrared and ultraviolet, to probe deeper into the star's structure and surrounding environment. These multi-wavelength studies provide complementary insights into Betelgeuse's physical properties and evolutionary stage. The recent metamorphosis and variability of Betelgeuse have sparked renewed interest in understanding its long-term behavior and potential evolutionary path. Astronomers continue to monitor the star for any indications of future changes or significant events. Each new observation contributes to a broader picture of how massive stars evolve and eventually meet their dramatic ends. In the realm of astrophysics, studying stars like Betelgeuse contributes to our knowledge of stellar populations and galactic evolution. Massive stars play a crucial role in enriching galaxies with heavier elements through processes like supernova explosions. By studying the life cycles of stars like Betelgeuse, astronomers gain insights into the origins of elements essential for planetary formation and life as we know it. Looking ahead, future space missions and ground-based observatories will continue to explore Betelgeuse and other stars in our galaxy. Advances in technology and instrumentation promise to reveal even more about the inner workings of these cosmic giants. From detecting exoplanets around distant stars to unraveling the mysteries of black holes, our exploration of the universe is fueled by curiosity and a desire to understand our place in the cosmos. In conclusion, Betelgeuse remains a celestial marvel that bridges the gap between scientific inquiry and cultural fascination. Its evolving nature, immense size, and potential for a spectacular supernova event make it a star of enduring interest and importance in the field of astronomy. As we strive to unravel the mysteries of the universe, stars like Betelgeuse continue to inspire wonder and awe, reminding us of the beauty and complexity of the cosmos.